Air pollution is really an umbrella term for many problems caused by both human and natural processes, but don't let the natural part fool you. Due to human activity, pollution runs rampant throughout the world, depleting natural resources, harming the atmosphere, and causing health issues in all living things. The leading concern when it comes to air pollution is the atmosphere. Gases like carbon dioxide and methane are released into the air in massive quantities every single day. These gases are extremely harmful to the atmosphere, specifically the ozone layer, which acts as a filter for the most of the harmful sun rays, which cause cancer and other bad things. In fact, many decades ago, a ban was placed on popular chemicals known as chlorofluorocarbons, or CFCs, which are largely used in refrigerants and aerosols. When CFCs are released into the air, they go up into the atmosphere and react with the molecules that make up the ozone layer, making them into other compounds which do not protect the world from harmful sunlight. Eventually, this depleted the ozone layer to the point where scientists discovered a hole had formed and the nations of the world took action against CFCs. In many countries, they were banned in all forms and have not been manufactured since. The hole in the ozone layer is still there, but slowly the CFCs are all being reacted with and the oxygen that makes up the ozone layer is being replenished. But CFCs are not the only threat to the atmosphere. Chemicals and particles such as carbon dioxide, fluorinated gases, methane, nitrous oxide, and many more are being released into the air every day. The specific molecules and chemicals I mentioned are known as greenhouse gases because when they get released, they trap the sun's heat into the Earth's atmosphere, which contributes to global warming. In turn, global warming contributes to air pollution because high heat intensifies the effects of certain types of air pollution. This creates a loop in which the problems of the air pollution only intensify and get worse. One of these problems is smog. Smog is a combination of the words smoke and fog. Coined at the beginning of the 20th century, the word smog describes a thick cloud that typically blankets cities and causes a decrease in visibility and irritation of the eyes and throat. There are two types of smog: industrial smog, known as London smog, and photochemical smog, or LA smog. Industrial smog is gray in color and is caused by byproducts of coal combustion and water vapor combining to create a thick haze which decreases visibility and can be harmful if breathed in. Industrial smog in London became known as pea soup fog, and everyone there grew accustomed to it until 1952, when it grew so thick that all traffic was stopped and upwards of 4,000 people died as a result of respiratory issues in the span of 4 days. Soon after, laws were passed which banned coal from being burned in certain parts of the city, and dramatically reduced the amount of smog looming over London's skyline. LA smog, on the other hand, is green and caused by warm, dry, sunny air mixing with vehicle emissions as well as VOCs, or volatile organic compounds, which can be found in most things from cow manure to cleaning supplies to paint and glue. The vehicle emissions, however, are the biggest components of photochemical smog. Car engines use an incomplete combustion process in order to go, which means instead of all the bad chemicals produced during combustion being used up, they are released into the air and unleashed on the environment. Photochemical smog needs one other thing in order to persist: the right geography. This is why it is known as LA smog. Since Los Angeles is located in a valley, the surrounding hills trap all the ingredients mentioned before and allow them to mix and cook under the sun. This is also true in places like Beijing, where mountains surround the city and photochemical smog has become particularly prolific. The different types of smog affect most cities around the world and contribute to poor health. Many governments have tried to put laws in place to prevent smog by doing everything from creating industrial districts to limiting the days cars are allowed on the road. But smog can only be stopped if people start driving electric cars and factories start limiting their emissions. Smog isn't the only symptom of the increase in human-driven air pollution. Along with the coal and vehicle emissions, volcanic eruptions, lightning strikes, and anything else that releases acidic compounds all create acid rain. Acid rain can erode away marble and stone in anything from statues to mountains, cause environmental issues such as changing the chemistry of soil, which messes with many important natural cycles, and make sources of fresh water unusable by decreasing their pH. Acid rain problems can be prevented in the same way that all other pollution problems can, through limiting the amount of harmful things put into the world. Creating more renewable sources of energy and making more effort to understand the problems instead of sweeping them under the rug is vital. Okay, question and answer time. I had a question about the problems caused by ozone depletion, so I looked it up. On EPA.gov, I found that the specific rays the ozone layer filters out are called UVB rays, and they can adversely affect the reproductive rates of most living things. I thought this was interesting because I didn't know certain types of light could affect internal organs, which aren't normally exposed to light ever. Second question. I wanted to find out more about the statues that have been eroded over time because of acid rain, so I looked it up. I found that many American monuments in Washington, D.C., such as the Ulysses S. Grant Memorial, have already been eroded by acid rain, and the National Park Service has taken steps to preserve them on the National Park's website. I think this is important because these monuments had huge cultural significance, and now future generations won't be able to experience them at their best. If you want to know more about VOCs, I would recommend viewing the TED-Ed video called The Science of Smog on the TED-Ed Lessons website because it gives a good and well-rounded definition of both VOCs and smog in general. I trust the information on this website is accurate because the video spends over a minute of its time harping on the amazing lessons of its author. Graph time. This graph shows the progress of the ozone hole for 2018. The gray shading indicates the highest and lowest values of damaging chemicals measured since 1979. The red numbers are the maximum or minimum of these values. The stratospheric temperature and the amount of sunlight reaching the South Polar region control the depth and size of the Antarctic ozone hole. The dashed line in the minimum temperature plot indicates the temperature below which type 1 NATPSCs can form.